Hello, students. This is Mr. Smith with a big picture overview of what Algebra 1 is all about. Okay? I just want you to remember, I want to simplify this as much as possible. There are really only three particular function patterns that we're looking at all year long. The first one is our linear pattern. Okay? That's the graph of a linear function. This is the parent equation right there. The quadratic, that's the parent function equation. This is the graph of it. It's a U shape. It's called a parabola. And then you have your exponential functions. The unique thing about exponential is the x goes from being a base to an exponent. Okay? So that's the overview of, that's the only thing they're going to throw at you on the STAAR test is these three types of functions. All right, now, within those three types of functions, you got your linear, your quadratic, and your exponential. Each one of them has key features that they ask about. In a linear function, they ask you about the slope, or they name it the rate of change, the y-intercept, or the initial value, the beginning, the starting point, the x-intercept, which is going to be your usually ending point of some sort in a word problem type situation. Then they ask you about the domain, which is all possible x values of a linear function from left to right, how wide, that has to do with the width of the function. And then the range is how tall, from the bottom to the top. Okay? That's a linear function, straight line. A linear can go up, it can go down, it could be undefined, or it could be horizontal. Okay? This is zero slope, this is undefined slope, positive, negative. Okay? Your quadratic, on the other hand, you got your vertex, which is the most important part of it. That's the turnaround point. That's the middle of the graph. It can either be at the top, which is a maximum, or at the bottom, which is a minimum. Okay? You got your y-intercept, which once again is where it crosses the y-axis, also known as the starting point or whatever in a word problem. And then your x-intercept, those are your roots, also called solutions. They just make up different names for all the same thing. Solutions, also x-intercepts, root solutions, and zeros. Same thing. They're going to ask you about, again, the domain, which is all possible x values from left to right, which usually is all real numbers. They're also going to ask you about the range. Okay, that's usually depending on if it's at the top of the graph, if it's upside down, it's going to be something that is less than or equal to whatever this number is. If it's at the bottom of the graph, it's going to be something greater than or equal to whatever this number is. That makes sense? Simple. The axis of symmetry is just that line that runs right through the middle of the graph. That's a raggedy line, but you get the point. It's always x equals something, some number. X equals some number. Okay? That's what it is. And it is always the x value of the vertex. So you have a vertex, which is a point, xy coordinate. Well, the axis of symmetry is always that x value, that number. So if you know that number, you know the axis of symmetry equation, that number that goes there. Last but not least, we got our beautiful, beautiful, beautiful exponential functions. An exponential function feature is the horizontal asymptote. Again, the y-intercept, or the initial value, the beginning point. That's true for all. Notice all three of those have that in common. Okay, all three of those have that in common. You got growth on this one, or decay. So that means it's either the graph is going to be going up exponentially, or it's going to be going down exponentially. Okay, so that's how that breaks down. Okay, and you got to be able to identify all of these different. I think it's 15 of these things, or so. 14, yeah, 15 of these things. All 15 from all four of these representations. A graph. Okay, a graph. You got to get it from an equation. You got to get it from a table, and you got to know how to identify all of these in words. Okay. In total, if you multiply 15, that's 15 little key features times all four different representations. That's about 60 questions on the STAAR test, and that's about how much they throw at you. So if you can do all of these to mastery, you will master the STAAR test with no problem.